at the first order differential equation, and then in this case, we want to see how we can solve exact equation, whereby one part of the equation is the exact derivative, and the other side can be integrated with respect to the function. So let's see how this is what we are saying: d dx of a function f of x and times y. So we have these two functions, f of x and y. Okay, and this will give us what? Derivative. This is a product rule. This is a product rule. So we're going to take this one constants and differentiate the second function, d dy respect to the function, respect to x, then plus the one we have differentiated here, then we'll take it constants and differentiate f of x. Okay, then the next thing to do now is to integrate this side. Okay, is to integrate okay, and then the other side, this side can be what? Can be integrated. Without wasting time, please let's go to questions and apply this. We have the following question and the general solution of the exact differential equation, and we have this following equation, and this is what? This is first order differential equation. For question one, the left hand side is a product of two functions. So, and that will give us what? D the x of two functions, which is the x y equal to what? Cos x. So we have established the general approach to solve exact differential equation. Okay. Then the next thing to do is to remove this from here, and that will be d of this function, and then cos x dx. So you multiply this place by dx, this side also by dx. So then you can introduce the integral sign to both sides of the equation. Okay, and when you have the integral of d of a function, it's going to give you the function. The integral of cos x is what? Is sine what? Sine x plus what? The constant of the integration. On the final note for this solution, you make y the subject, and then you have what? You have this. So question 2, we have this. This is equal to d dx of products, which is exponential, the first one, which is your f of x, according to the standard rule. Okay, and then by what? Times what? The second function, y, equal to this place. So then the next thing to do, can you remove this one from here? So if you do that, you have d of the function equal to what? This one, dx. So, and d, integral of d of a function will give you what? That function equal to this one. We're going to apply integration by parts, because this is integral of two items. Let's go to this. So then this one, let's make it a u, because it's become simpler on differentiation. So u is what? U is this. Then the u is equal to what? Dx. Then the v is what? Is this. Then integrate this and this. So v is what? V is this. So then we now have this side, the left side, equal to, if there's a formula for integration by parts, and we have dealt with integration by parts. So please check integration by parts on this channel. So the formula is uv minus what? V u. So we're going to substitute. Your u is what? Your u is this. Your v is this. Then minus. Your v is what? V is exponential to power x. Then the u is what? The u is equal to dx. The next thing to do now is to make y the subject, and that will be equal to what? Make y the subject, and that will be equal to this times exponential to what? To 2x, then minus If you integrate this one, integral of exponential will give you that function, but that will be what? This one over this one. And that will be equal to what? That will be equal to exponential to 2x plus what? Plus. Don't forget, this one is going to have plus c. So that will be what? Plus c over what? C over this. So if you, on the final note, this part will be equal to c times exponential to power x. So we now have y equal to this one minus this, then plus c times exponential to power x. So that's what we have for that solution. When you divide this one over this, okay, you apply this one, you have the same base, apply your indices, so you have exponential to power x minus what? Minus x, and that becomes what? That becomes 2x. So that's that on that question, on this question, and that will take us to the third question. The third question, we check it. We have this, which will give us ddx. You give us ddx of sine x times what? Times y equal to what? Equal to 3. Okay. And if you use your product rule, you can experiment it and see if it's going to give you back the question. I mean the left side of the equation. Let's apply that. This is your f of x. This is your f of x. Take it constant, differentiate your y, then you have the y dx. Now keep the y constant and differentiate what? Sin x. That's what? Cos x. So that's that. Then the next thing to do, can we integrate both sides of the equation? If you put your integral here, and let me quickly, you can move this dx to the other side. You can move this dx to the other side. So we just have d, integral of d sine this times what? Integral of what? 3 dx. And anytime you integrate d of a function, integral of d of a function, you have this. You have this. This one, the 3 is a constant. You are only integrating dx, and then integral of dx, I mean d dx, will give you what? Will give you this. So that will be equal to 3x plus what? Plus c. Then the final conclusion is to make y the subject 3x over sin x, then plus c over sin x. And that will be equal to 3x. This one, 1 over sine, that will be what? Cosec the function, and then plus what? C cosec x. 1 over sine is cosec. 1 over sine is what? Is cosec x. Okay, and that's the answer for the third. And you can also express your final answer as what? 3x cosec. The shortened form is this. Okay, cosec is written as what? CSC of the function, then plus what? C times what? CSC of the function. The fourth one, check it. This left side is a product of two functions. So we're going to have d dx of 1 over x, okay, and then times what? Times y equal to the right side of the equation. And if you differentiate this, you're going to have back the left side of the equation. So in this case now, we can remove this dx here by multiplying this place by dx, multiply this place by dx. So we have d of this product, and then this dx. Then integrates both sides of the equation. So d of a function, okay, will give you that function. So you have this equal to integral of this will give you what? Integral of exponential will give you this. Then plus what? Plus c. Can you make your y the subject, okay, of the formula? So we have y equal to. I think this is a fraction. You can multiply through the equation by this function. So we have this, then plus what? Plus this, and that finished the fourth question. Okay.